So, hi guys. So a formal introduction of myself. My name is Kawu. I'm a cloud solution architect specialized in data and AI. So, as some of you have been in DataFest, you've probably seen some of my colleagues also being a cloud solution architect. So I'm part of the customer success unit, CSU, and our responsibility is to enable our enterprise customers to succeed on Azure. So we also have my colleague, Jerome Vigne, on the call. Unfortunately, he cannot make it on site because of travel accommodations. But Jerome, do you want to say hi?
Yeah. Hi, everyone. Nice to meet you. I'm Jerome Vigne. I'm a colleague of Kao. We're on the same team. We're also cloud solution architect. My specializations are more around DevOps, automation engineering, and infrastructure as code.
Nice. So you guys can all hear Jerome okay, right? Yep. Great. And you guys can hear me okay? Perfect. So today we're going to talk about productionizing Databricks. And especially we're going to take a deeper dive into the CI/CD process and how to implement CI/CD for Databricks. So can I get a show of hands? How many here consider themselves as data scientists? No one. Great. How about DevOps engineer? No one. Why are you guys here, guys? So how about software engineers in general? 3, 4, 5. Great. So yeah. That's great. That's we're at least getting some participations. That means that people are not falling asleep after lunch. But this is really a level 300 content for Databricks. So if you have minimal experience with Databricks, or if you have minimal experience with DevOps, this is probably not the best presentation for you to be in. So I'm gonna briefly go over the agenda, and if you think that this is not what I'm looking for, feel free to head out and join other sessions, and I will not be offended, but I might make fun of you. So we're going to start by talking about the agenda that we're going to cover today. We're going to briefly talk about Azure Databricks, if you haven't heard about it already. We're going to talk about Azure DevOps, which is our CI/CD tooling for this live demo. And we're going to talk about some of the considerations that you need to take into account when productionizing Databricks. And we're going to wrap the presentations up with a live demo and a deep dive into the CI/CD implementation of Databricks. And the slides will be shared after the presentation, so don't feel like you have to take pictures or take notes, that sort of things. So what is Azure Databricks? So in a one-liner of Azure Databricks is basically manage Apache Spark on Azure. That's what it is. But what does Azure Databricks offers on top of Apache Spark? That's what makes it really interesting, and we're going to talk about that today. But before we talk about Azure Databricks, we have to understand what Apache Spark is at a high level. So Apache Spark is an open source, it's a unified in-memory data processing big data analytic platform. So it supports various big data workloads, such as interactive queries, machine learning, stream processing, and graph computations. And all of those centers around the Spark core engine, which is run in JVM. So before Spark was so mainstream, what are some of the ways that you would accomplish these big data workloads? For example, on Azure, you would use HD Insights to do interactive queries using Hive. You would use Azure Machine Learning to kind of implement your machine learning models and to manage the life cycles of it. You would use Azure Stream Analytics to stream from event hubs or Kafka and do some real-time processing on that front. For graph computation, you either need to write your own custom logic and take advantage of the Gremlin API on Cosmos. But with Spark, that makes it possible for you to accomplish all of those workloads under one platform, and that's what makes it really popular nowadays. So with that, we're going to talk about Databricks. So what does Databricks have to offer on top of Spark? So Databricks is basically an abstractions and decorations around Spark. At the top level, we have the Databricks workspace, which contains all of the other entities that we're going to talk about. First entity, notebooks. So if you're a data scientist, you're probably familiar with Jupyter notebooks, where you can write your Python code, write your data explorations, data analysis code in different cells of the notebook, and having the ability to execute each notebook interactively. And that's what makes it really powerful and really enticing to a data scientist. And Databricks supports that. In addition to that, Databricks supports collaborative workspace, which allows different data scientists to work on the same notebook, like how you would do it on Google Docs. Also, clusters. So how many of you have deployed your own Apache Spark clusters before? No one. Great, because you don't want to be in that boat. Deploying Apache Spark clusters is terribly confusing. And what Databricks has to offer is a few lines of configurations. And with the click of a button, you can deploy a clusters with as many nodes as you want, with various runtime that you want, and with different Python versions that you want. All of those built in. That's what makes Databricks really strong. On top of that, it supports libraries. So when you deploy a Databricks clusters, you can define the Python dependencies. You can define the Maven jars to pull down from these central repositories, and to establish a development environments for the data scientist. And last but not least, jobs. Many of you have probably engineered data pipelines that runs every night or every day. And this is what jobs for, the ability to execute your notebooks on schedule. So Azure Databricks is actually first-party offerings on Azure. And what does that mean? That means that on top of everything that you've heard before, it also offers seamless integrations with a lot of our Azure offerings. So for example, you can launch Databricks Workspace directly from Azure Portal, which is not possible from other third-party offerings, by the way. It also integrates with our Azure Storage and Data Lake Storage, which means that you can mount those storage as drives or as mounts onto your Databricks clusters for accessing your data. It integrates with Active Directory for user auth, which means that you no longer have to maintain two identity platforms for your third-party service versus Azure. And it also offers a number of connectors to integrate with other data sources like SQL servers, SQL Data Warehouse, Cosmos DB, Event Hubs, and Kafka. And at the end of the day, you only get one bill from using Databricks on Azure platforms, which is not possible again with third-party offerings. Because for third-party offerings, you have to pay for the Azure infrastructures as well as the licensing cost. Any questions so far? Sounds like I bore you guys. So with that, I'm going to pass it over to Jerome to talk about Azure DevOps and how that integrates with Databricks.
Perfect. Thank you, Kao. Yeah, I wanted to give a refresher on Azure DevOps because that's what we're going to use in this case to work with Databricks. Azure DevOps is really, just from a branding perspective, for you guys who've heard it before, that's the new name of VSTS. In former it was TFS when you had it on-prem, then VSTS, and now Azure DevOps, that you can have completely cloud-based. And Azure DevOps is a suite of different solutions and tools that are very well integrated to one continuous experience, where we want to offer you everything you need to do your software projects, from planning it at the beginning, from managing it, to developing your code, keeping track and version controls of your code, testing your code, deploying your code, and getting feedback from the field or from your users back into your project management system. And so the main 5 areas on which that are in DevOps is, starting from here from the top left, is Azure Boards. So that's where, for example, a product manager would create all of the work items, assign work items to some of his software engineers, track the progress, plan sprints and releases, things like this. The next step, and we're going to be using this a lot, and in the live demo we'll go fairly deep into pipelines, is Azure Pipelines. So that's where you define your builds, your tests, and then how you deploy continuously to any platform that you may choose your code. And then another central piece is obviously Azure repos. So a Git repository that is cloud hosted and private, where you're going to manage your code and do version tracking of all of your code. Now, the beauty of it is if you use all of this in Azure DevOps, that you can now link work items to code branches, and Kao will do this live in a minute. And then you can see how work items populate all the way through a branch that gets merged, and then through your dev and your low environments all the way to your production. We're going to be leveraging these two things together a lot in our demo. What you also have is Azure test plans. That's where you can define manual or automated tests to run as part of your pipelines. And then Azure artifacts. So anytime you have packages that you want to share across the team, you can have them in Azure artifacts. And so just one more slide on Azure Pipelines, and you'll see it live very, very quickly. So that's the cloud-hosted pipelines, Linux, Windows, or Mac OS. We have a wide variety of hosted agents. You can also bring in your own agents if you wanted to. We support any language, any platform, and then you can deploy against any cloud. So it can be, in our case, we're going to deploy against Azure. You could deploy against AWS, the GCP, against your on-prem environment. It's very extensible. You're going to see that all the tasks, we have first-party tasks that we have written ourselves. But for everything that you can't do with those, there's a marketplace experience, a little bit like the one you know from Visual Studio Online, maybe, where others can publish extensions that you can then pull into your Azure pipelines. Everything is based on YAML definition, so you can export pipelines that you've created as YAML file. You can import the YAML file. Containers and Kubernetes support is also built in, so you can pull images from your Docker Hub repository or for registry or from Azure Container Registry, for example. And the beauty of this tool is we're going to leverage all of it in our example. But I have customers who only use parts of it. I have customers that have all of their code in GitHub Enterprise, but then they do want to leverage the pipelines here and use the Azure pipelines. I have customers who use Azure Repo, so the repository solution here, but then as a build agent, they'll have their own Jenkins machines. And then for release, they can use a third party like Octopus Deploy, for example. So really, you can mix and match all of the different parts of that tool set. I think it's back to you, Kao.
Yes, with that, we're going to go into a case study. So a customer, CONTOSO, approached us a few months back saying that, all right, they want to build a machine learning models for predicting Boston home prices based on a number of features. For this live demo, we're not going to talk about the actual machine learning models, but more on the CI/CD portion. So CONTOSO has a team of 50+ data scientists within their org. And after they learn about Databricks, they think that it is a good fit for what their use case is. Few reasons, but two primary reasons. First, Databricks is based on Apache Spark, and they're a big fan of open source technologies. They have prior Python experience as well as Spark experience. It also supports, Databricks supports ETL in a massive and scalable way, as well as it supports machine learning using Spark MLlibs. In addition to that, they want a solution that their data scientists can collaborate together on. And having the notebook UI experience, which we'll show in a minute, really helps that cause. So now their their corp IT approached us saying that, how do we operationalize Databricks in dev, production, QA environments so that we can work with the data science team? And that's what we're gonna kind of look into. So the journey went through a few iterations. So the first iteration is the corporate IT, they don't want to control the data scientists. They want the data scientists to go as fast as they can. So they did establish a governance models. So what ended up happening is that these groups of Databricks or these groups of data scientists went on and created their own Databricks workspace for each data scientist. And within each workspace, they created many numbers of Databricks clusters so that it became really unmanageable. So corporate IT came to us saying that, all right, well, what should we do? And the thing here is we really need a governance model for the Databricks workspace. And what we suggested is that you should have one Databricks workspace per environments that you're going to deploy it in. So one Databricks workspace for dev, one for QA, and one for prod. And for the dev workspace, it is important to note that you need two types of clusters. One is the standard type of clusters, and the other one is high concurrency clusters. So when you create a Databricks clusters, you have the capabilities to choose which type of clusters that you want. So for standard clusters, it is usually great for running jobs, or having one data scientist assigned to that clusters and use them. But when you want multiple data scientists to use the same clusters, you should use the high concurrency version of it. What that provides is fault isolations, because what it does behind the scenes is that it will plan out all the resources per notebook executions so that it will maximizes the resources utilizations on the clusters while minimizing the latencies that occurs in that clusters. Also, high concurrency clusters brings you the features of table ACLs. So if you were to use a standard clusters, you cannot apply access control on the Databricks table itself. But when you enable high concurrency, you can set up ACLs, access control, on the Databricks tables. So you can say user A has access to table A, and user B has access to table B. But the caveat for high concurrency clusters is that it currently only supports Python, SQL, and R. It does not support Scala. Questions? I see some smiles. All right, so
how soon is Scala going to be certified?
I don't know if that's on the roadmap because there is some technical difficulties revolving around threat management in order to create that isolation experience in high concurrency clusters. But I can double check on that if you follow up with me. So now what we have is one Databricks clusters in each of the environments, dev, QA, and prod. And we have, and each workspace contains multiple clusters for different workloads. That's great. Data scientists are happy, we have a governance models in place, and we're also using Active Directory for user authentication.
I have a question about the environments. Are all these three separate workspaces reaching to the same storage since you're dealing with big data, or you're also replicating the data?
Yes, so the question is, are these various Databricks workspaces using the same storage, right?
Yeah.
So that depends on how your storage is architected. So for this particular customers, it makes sense for us to use Data Lake Gen 2, which is the storage layer that we're using. And we have a Data Lake for each of the environments that we have. So one for QA, one for dev.
So if you have like 50 terabytes of data, you're replicating it in three.
Well, yes, between prod and QA, if you want an accurate representation of your data. But for dev, you can always minimize it, right? Because it's more on the data representation itself that matters. Yes?
Is Gen 2 required, or is that?
It's not required. You can use blob storage, etc. But Data Lake Gen 2 offers scalable features on top of blob storage.
is a Databricks workspace, is that an instance of Databricks in Azure? So you created 3 instances of Databricks, or is that one instance and workspaces within?
Right.
One.
Yeah. So to think about workspace, you can think of the workspace as a Azure resource that you would deploy. So similar to, let's say, an Azure SQL database. That's one instance, one Azure resource. And a workspace is that one resource. So we'll see that in a bit during the live demo, and that will clarify it. Any other questions? All right. So everything works out great for the data scientists, but now there's another problem, and that is the problem that we kind of alluded to. The library's dependencies is tied to clusters creations. So whenever you create a clusters, you have to define the Python dependencies or the Maven dependencies ahead of time, which means that for different workloads, workloads that has conflicting Python dependencies, the way out is to create a new clusters. But not to worry, Databricks has a feature that fixes that. So Databricks offers you a notebook attached dependencies, which offers you a notebook isolated dependencies or a notebook isolated ways of defining your dependencies. And here's an example of that. So basically, it takes advantage of the DB utils, which is the Databricks utility functions. And the recommended way is for you to define all your dependencies in a notebook that's not within your code, your ETL pipelines. And when you're actually using those dependencies, right, in your ETL pipelines or in your machine learning code, you just use this magic command run, which runs your external Databricks notebooks before it runs all the other cells. So in this case, what we're doing is that we're calling this install dependencies notebook, which we've seen above, that we're using to install Python packages. And then afterwards, we're just using it as if this was defined in the notebook that you imported it into. So that's great, because now we can slim down the number of clusters that we have to create for different big data workloads. So at the end of the month, Azure billing comes around, and your finance department comes to you and says, what is all this? We're paying unnecessarily expensive because CONTOSOs did not enable auto-scaling nor auto-terminations. So auto-scaling is the autopilot options that Databricks built on top of Spark. So depending on the workload, depending on the resource utilization of your clusters, Databricks has the capabilities to automatically scale down and scale out to X numbers of nodes that you define as you have defined here, the minimum workers and maximum workers. Auto-termination. Auto-termination is when you are not using the clusters for X number of minutes, then the clusters will shut itself down, and that will not incur any charges to you as an end user. So if you were to take away one thing, right? Don't make your company pay extra. Enable these. These are like 2 buttons that you have to click. So when it comes to operationalizing Databricks, right, we talk about, all right, how do we handle Databricks in dev environments? But now let's talk about what are some of the considerations you should take account when you're deploying Databricks in QA and prod. So identity management, as we talked about, Databricks integrates seamlessly with Azure Active Directory so that you have one platform to manage all your identities. But what if you need to apply access control? With that, you use Databricks, Databricks ACLs. So Databricks itself will support user authentication from Active Directory, but it does not support authorizations from Active Directory. So you have to use Databricks, either CLI or the UI to manage that. The other thing, what if you're storing passwords? What if you're storing client secrets in your notebook? Well, what is the way around that? The way around that is to use a centralized secret management system like Azure Key Vault. So this feature is still in preview, but Databricks integrates seamlessly with Azure Key Vault so that you can store a secrets in Azure Key Vault, and you'll have a way in Databricks to retrieve that. Network security. So if your corporation operates in a hub and spoke network topologies or has some stringent network requirements, you can use Databricks VNet injections to inject the Databricks deployment into your VNets. And at that point, you can do all the networking magic that you want. In terms of monitoring, if you need to monitor the system telemetry of Databricks clusters, you can use Azure Monitor. If you're looking for a more application performance monitoring, you can use Application Insights. And Application Insights is basically an SDK that you have to code around it for the metrics to be correlated in a way that makes sense. So now we've talked about all the logistics of Databricks, but when we're deploying Databricks, right, how do we ensure that every Databricks deployment is controlled? And with that, we use infrastructure as code. And on Azure, as many of you will probably know, we have Azure Resource Manager, the ARM templates for deploying Azure resources in a infrastructure as code manner. But Azure also supports Terraform. So if you're coming from an open source kind of realm, you can always use Terraform. In terms of automation, right? If you need to implement CI/CD pipeline, automation is a must, and we'll see that in a bit. Your choices are AC CLI, PowerShell, or Databricks CLI. So in particular, we're interested in the CI/CD pipelines. Few reasons, because data scientists usually are really comfortable in their Jupyter Notebook environments, and they don't want to think about anything else, or we don't want them to think about anything else. When we want to create a seamless experience for the data scientists to develop in. So what we need from a CI/CD pipeline perspective is for changes and updates that are made in the dev environments to be propagated to the QA and prod environments. That establishes an audit trail of changes for the data scientists, as well as taking away the human components of copying notebooks from dev into prod. And the tooling that we're going to use in this case is Azure DevOps.
Perfect. So you've survived the PowerPoint slides, and now we're gonna get hands-on with Azure DevOps. And so during the next 2 minutes, how it's gonna work, or the next 10 minutes, Kao is gonna be a data scientist. So everything that he talks and shows about is from the data scientist point of view, and I'm gonna be playing the DevOps engineer. So everything I talk about is gonna be centered around Azure DevOps and what we did here. So let me go, and I hope this is the right tab here. Yeah, let me go into Azure DevOps. So I hope most of you are familiar with this UI. So that's Azure DevOps. The different boards, repos, pipelines that I mentioned earlier are all here. We're gonna dive straight into the repos. And please interrupt me with any questions, or Kao, if you see any questions in the room, let me know. We can make this part very interactive.
Yep.
So this is the repository in the master branch. Okay, so that's my single version of truth at the moment. And here, what's the most important is I have two folders, the ARM template folder and the notebooks folder. So in the ARM templates folder, that's where I have my JSON packages that I'm going to send against the ARM API to deploy anything that I need on Azure. So I'm sure a lot of you have seen packages, documents like this before. This is our declarative way of specifying which resources we want in Azure, what size, what name, and things like this. So I'm going to use always the same template file, but then to populate my different environments, I'm going to use different parameters files. So the parameters in dev, they're going to be different than the parameters in prod or in UAT. And then the other part of this repo is the notebooks. So these are actually the notebooks that Kao works on and the rest of the data science team. I'm not going to go into them here. Kao will show you this in Databricks. But all these three are here because the moment Kao or his team makes any changes and merges them into the master branch, I want to kick off a build and then a release that will capture all the newest version and then populate my different Databricks workspaces with the newest version so that another team can pick up where they left off. So with this said, we're not going to look at the pipelines now. First, I'm going to show you real quick in the Azure portal what we have deployed and where my world ends and the world from KO begins. So this is KO subscription, and the two resource groups to look at are the Databricks CI/CD RG. That's our dev environment. We're going to dive into, and then here we have the same that is a prod environment. Okay. So these are in different resource groups. Think of resource groups as just logical bindings of Azure resources. In our case, we put them in the same subscription, but you could, and I would highly recommend having your prod in maybe a different subscription, and then really tying down the rights of each individual in prod. This way you can enforce that only Azure DevOps pipelines can make any changes in prod, and nobody can do any manual changes, and this way you don't have any drifts, configuration drifts. So if we look, what we're going to use here, we have our Databricks CI/CD Key Vault. That's where my security ops team has created secrets and then stored in here. And I, as a DevOps, you'll see that's in the pipeline. I actually never get access to the secret. All I get is a pointer to the secret and enough rights to be able to retrieve the secret, but always as an encrypted value. And then I have the storage account where KO's team have all of their data. And then I have the actual Databricks instance that is deployed here. So KO, I think this is where our world merges. You can take over.
Yes, I'll take over from here. Thank you, Jerome. So as a data scientist, right, I don't want to leave my Databricks workspace because that's where majority of my work relies on. So right now I'm launching Databricks, and behind the scene, it is using Active Directory to sign me in as my Active Directory account. And in here, there is the various entities that I talked about earlier. We have the workspace, which is basically a collection of notebooks. And we have data, which we didn't talk about, but is basically the Databricks abstractions of a database and tables similar to Hive tables. And here we have the clusters UI, where you can create an interactive clusters as well as job clusters. And this is where you can create high concurrency clusters versus a standard clusters, where you kind of configured auto scaling versus auto terminations. We also have the capabilities to create jobs that you want to execute every now and so. So if we go into workspace now, we can see that there is a folder in the top level directory called master build. What this folder contains is actually accurate, up-to-date representation of what is in Azure repo in the master branch. So if you recall earlier, there is several notebooks under Azure repo, right? We have 3 in particular. We have main, 00 environment setup, 01 featureizations. And that is exactly what is shown here in the master build. And all of that deployment is through CI/CD pipeline, which will be explained in a little bit. But let's walk you through what the notebook is doing in a nutshell. So we have the main notebook, which is acting as the driver. So all it does is call other notebooks. So at first, we call it the environment setup to kind of mount the storage onto our Databricks cluster. Then we actually perform some lightweight data preparations on the data that we get back. So now let's take a look at environment setup. So here, what I'm doing is I'm creating a function that mounts Azure Data Lake Gen 2 onto my Databricks clusters. And to note, in order to do that, I have to use OAuth. And with OAuth, there's a client secret that I need to store. But I'm using the Databricks integration with Azure Key Vaults to achieve that, so that the data scientists don't have to worry about secrets ever. And in this case, in my data lake, I created 2 zones, 2 file systems, 2 folders, however you want to think about it. But there's this raw zone and there's the refined zone. And what I'm doing is I'm storing the raw Boston housing data that I want to analyze in the raw zone that I'll never write back into for this pipeline. And I also have a refined zone where I'll be writing all the clean data, all the data that has been processed into. So I've ran this Databricks notebook this morning because this saves us time from the live demo. But questions?
Yeah, so when we actually talk about the raw data, right, so do we call it as unstructured data or structured within some structure around it? So when we say raw data, what do we mean by that?
So raw data is a combination of both. So there is sometimes structured data like CSV, Parquet, etc., depending on what you're dumping out the data with, right? But there's also a possibility of unstructured data, like semi-structured data, like JSONs, which is not really relational, but has some sort of structures to it. For this demo, we're gonna work with CSV files.
Yeah.
Another question?
Yeah. So how are you connecting to the data lake from Databricks? Is the same user there in the data lake as well?
Good question. So the answer is no for this live demo. So the way that I'm actually authenticating against the data lake is through client ID and client secret. That's one way of doing it. The other way is actually using Active Directory credential pass-through, which means that since I'm logged into Databricks as myself, Kafang, I'm able to establish the access control from the storage layer so that when I'm accessing Data Lake Gen 2 through Databricks, I'm still myself. So all the access control, so perhaps I don't have read permissions on this particular files, then I will not have read permissions through Databricks. So that's Active Directory credential pass-through. If you want to learn more about that, come talk to me and I'll show you some documentation. Any other questions? Perfect. So in this case, I've ran the notebooks in the mornings to save us some time. So all the storage is mounted to the Databricks clusters, and this Databricks cluster has been up for about 5 hours. I set auto terminations to 10 because I don't want it to incur extra charges. So now let's take a look at the simple data prep pipelines that we have. So in this case, what we're doing is we are reading a file from the raw zone, in particular the Boston housing raw data. And as you can see, it contains many columns. All of the columns from the first until the second to last are what we call as the feature columns provided by the raw data set itself. The last column is the target as to what we want to predict. And that is the median home value. So in this case, what we've done is we've done some analysis on the data set itself, and we realized that there are only two features that really matters when we're predicting home value. Number one, the number of rooms in the home. Second, the crime rate in the room. Again, this is for live demo purposes, and that's why it's so simple, but that's what we have. So after we figure out what the relevant features are, we do a select on the data frame to select only the columns that we care about. And that's why we have minimized the number of columns from X amount to 3. And afterwards, what we're doing is we're doing a random split on the featureized data frame to get us a training and testing data frame so that we can later on use down the pipeline for machine learning models creation. So this is actually where we write the data frames. And to show you that it is actually what this is doing, let me run another command real quick. So this notebook is ran just before I arrived into the room. And basically what this is doing, it is reading the refined data lake. So basically what is currently in data lake Gen 2 right now as of for the training data and the testing data. So the things to note here is that there are only 3 columns for each of these data frames. So now as a data scientist, right, I want to have the ability to change my current notebooks in dev environments, and I want that change to be propagated into QA and prod. without me having to do anything else, without me having to leave this experience. So what I'll do is I'll actually make a change on the featureization notebook. And before I do that, the process goes like this. So first, I'll have to go into Azure DevOps to create a new branch, a feature branch, or a work branch, as I will call it. So I'll call it prep branch. And I want to create this branch based on the master branch. And as Jerome talked about Azure DevOps as an ecosystem of different products, you have the capabilities to link it to an existing work items in Azure Board so that you can track, for project manager to track the current commit process of your tickets. But in this case, we don't have any work items, so I'm just going to go ahead and create the branch. So now the branch is created, and I'm in my own branch. So what's next? So I have to, as a data scientist, all I need to do is come into my dev workspace and clone this repo because this is the most up-to-date representation of the master branch. And as a best practice, you should always name the clone folder to the name of the new branch that you created, because this is what you'll be working out of as a data scientist. So after I created a clone, now I can start hacking around. So what I'll actually do first is I'll sync this notebook into Git. And in order to do that, I'll click over here on this revision history tab. And a little below, you can see that it is saying that I'm not linked to any Git repository. So I'll go ahead and link it real quick, set it up. And because I've set this up for other notebooks in this workspace before, some of the metadata is captured already. So this is indeed the Azure repo that I want to link into. And in this case, I don't want to commit directly into master, and because no one should ever do that, we should always create an audit trail for that. So now I'm just going to sync it to the branch that I just created in Azure DevOps. In this case, because of the file structure that has been in place, I need to change the path in the Git repo that I'm saving into. So instead of notebook, Databricks, or notebooks, my branch name with the notebook name, I'm just going to do this, notebook. All right, and click save. So now what it's doing behind the scene, it is actually syncing your notebook to Git. And here you can actually see the list of commits from Git itself. So which means that now if I were to make any changes here and commit it, it'll be reflected in real time on Azure Repo or GitHub. So now I have done some analysis, and I realized that there's another features that I want to include in the training and testing data sets. In particular, I want to understand where I know for a fact that including the percentages of low-income people around my home will impact the median home value. So what I'll do is I'll comment the above out, and I'll include a different feature columns in this. To note, I'm not actually running any Databricks code as of now, so nothing has been executed in actions yet. So what I'll do right now is to, let's say, attach, actually, let's not do that. We'll let Azure DevOps run the code for us. So now if I go under revision history, what this shows is the diff of your current notebooks with what has been committed into Git. So now you can see that, all right, there used to be, or there used to not be a hashtag, but now I added it and I removed the hashtag from the second line. In order to create a commit, I click over here, save now, and I just type in the commit message. So in this case, including ls stats in features. And when I click save, what Databricks will do is that it will actually commit it to Azure Repo, which we'll see in a second, and again, sync it back. So with that, do you want to take it over, Jerome?
Yeah, so Kao, as of now, has committed then his adding his third feature for his analysis into his branch. So if we go back here, there we go. So right now we have two branches. So the last thing, Kao, you can do before I take over fully is, because I think it's a little easier with your mouse than with mine, you can create a pull request so that, well, let's say that Kao is done, he's happy with what he did on his branch, and now he wants to merge it back into the master branch. He can do this right out of DevOps here, for example.
Right. So let me do that real quick. So now I've committed a new commit into my branch. So what I need to do to merge the change into master is to create a pull request. So here's a handy dandy header to tell you that, all right, a change has been made in my branch. Do you want to create a pull request? So now I'm onto the UI for creating a pull request. You can modify your title. You can modify the descriptions. You can add some users as reviewers for your pull request, and you can attach any work items that you have on your Azure board. And here we can see the actual change that is made. So again, we are just uncommenting the second line and commenting the first line. So now if I click create, that's great. So now this PR has been created. So if you have any assigned reviewers, the reviewers will actually have to come in and approve the PRs before you can complete it. When you complete it, that's when the actual merge happens. So now I'm just gonna complete it, and then I'm gonna enable the options to delete my feature branch after I merge. Perfect. So now with that merge, Jerome, you want to take that over?
Yeah. So now Kao has merged his branch into it. So the nice thing is that all of his commits coming in. So we can see here, the ARM didn't change. Nobody changed that. Terraform part didn't change. But in the notebooks, 2 minutes ago, there was a change made. It's 3 minutes ago now. And here we see it's the commit from Kao, including LSAT, into the features for his model. So because we've set it up in CI/CD, we'll go straight into the pipelines and look at what's happening right now. So this is my build pipeline, and we can see there's one going on right now that's been triggered. So let's look at the definition, and it's already done running, the number 75. We look at the definition. Here, the definition is pretty straightforward. We have multiple copy jobs, so we're going to copy all the folders that are in ARM templates, and we're going to stage them to a staging directory. We're going to do the same with all the notebooks, and then we're going to copy a file called runconfig. That's a JSON file that we need to execute a job against the Databricks CLI later on. I talk a little bit more about it in the release pipeline. So all in all, I've just copied the latest versions of the files, basically, to a place where the release agents will be able to grab them. Let's go to the release, and we see right now we have one going on. The whole release from dev over to prod takes about 18 minutes. So I'll be talking about them while they perform, and then we can look exactly into what they do. And please interrupt me with any questions along the way, okay?
All right, we have a question in the room.
Perfect.
Yeah. So once your build pipeline is completed, does it automatically trigger the release pipeline? Or is there any unit test also happening in between?
Yeah, Jerome, the question is, once the build pipelines finishes, does it automatically triggers the release pipeline? Is there any unit test that is triggered?
So in our case, it does, yeah. But you could set it that first you have to verify some test plans or get approval from one of your peers. Here, just so we save some time, we go straight into the development, and the little bit of testing that we do, we actually have it kind of in the dev pipeline where we're going to run the notebook to make sure it runs without any errors and it's able to mount the storage and things like this.
Is there any scope of automated unit testing here for Databricks?
So the question is there any automated testings built into Databricks?
Yeah, for Databricks.
So the answer is no. For the unit test, you have to kind of implement them yourselves. But again, this is Azure Pipelines really a generic local if you want it to be, or YAML definition if you want it to be. But you can integrate, you can create different blocks and kind of put it into various parts of the pipeline. So if you want to build your own automated test, you can create that and simply put that as one of the tasks in the pipeline itself. But yeah, Databricks unfortunately does not provide automated testing out of the box.
So here at the first level of the pipeline, we can see I have different stages. One is my dev environment. We're skipping UAT here. We're going straight after this to production. But so they're twins of the exact same tasks, just with different variables and with different environments. So I can deploy it over multiple subscriptions. And if we look here, what we've set up on this agent, and here we're using a hosted Visual Studio 2017 agent. But as we mentioned, there are tons of agents that come out of the box, macOS, Ubuntu, Linux, and then Windows containers also. We're very happy with VS 2017. We're going to use this. So the first thing I'm going to do here is I'm going to actually get all the secrets that I need to run. So these are secrets, for example, the one to be able to authenticate against the Databricks CLI. One of the SecOps team created the token, put it in into the Azure Key Vault, and then gave the service principal that represents this pipeline, that this pipeline uses to make releases. It gave it the necessary access rights to retrieve the secret. So all I know is just how the secret is named. I never really get the secret, which is really good. This way I don't save it anywhere. I'm going to get all the secrets to be able to use them later. And then the next one is I'm doing an ARM deployment. So here, just to go through, I create or update the resource group. The resource group I have as a variable. So that's, in this case, it's going to be dev resource group. In the next stage, it would be the prod resource group. And then the artifacts that I'm going to deploy, they're in my template file. So here, if I look on the ARM templates, it's my template.json. And then the parameters, these are, again, specific to my stage. If I go and I see this is what gets mounted to the agent from the build copy jobs, I see ARM templates, and then here I've selected the dev. And in another stage, I could use UAT or prod. But this way, I always use the same template file. So he's going to do this just to verify that the Databricks instance still exists, the storage accounts that Kao is working with still exist. And if I added any more things, I could add it here. And then we're going to go actually into using Bash to work with Databricks. So the first thing I'm going to do on this agent is to install Python. And then the next thing I'm going to install is actually the Databricks CLI. So here I do Python pip install Databricks CLI. And then I'm going to authenticate against the Databricks CLI. So the Databricks location is going to give me the REST API endpoint against which I need to authenticate. And I'm going to pass the Databricks token, which is in a variable. So if we look at the pipeline variables here, on the variable groups, here, for example, are your, no, they're further down the token. This is where the secrets are going to be kept, the Databricks token. But I've defined all of the variables that I wanted to use here under the task variable, under the variable part. Okay. Then the next task, I don't need Bash for this. I could do this in Bash. I grab all of the notebooks and then I deploy them to my Databricks. And in the next one, I'm gonna create the notebook run document. So that's a JSON package that basically is gonna do the REST call to tell him, please run this notebook. And in our case, the notebook, the only one we need to run is main, because that's the one that runs featureization and the preparation notebook. And the next step, and I don't have time to go through this, we can share, there's a very good article on how to do this. He had great ideas on how to use Bash for this. Here we're gonna just submit the job. And what will come back from the REST API is a job ID or run ID in this case. And then in the last step, I actually go and look up the run ID and try to find out if the job was successful or not. And I do this every 30 seconds. So let's look at our run right now because we only have 5 minutes left. We're going to look into release 32. We're still working on the dev environment. But here we're on step 12 out of 12. So he's almost done. He's actually running the job. But here, this is a great feature of Azure DevOps. I get a very chatty logs on all the things that he does. So I can see which ones I succeeded. I can open and view all the logs that were produced. And using verbose, I can make this more chatty or not. And here, he's waiting for Databricks run to complete. So right now he's looking if I successfully managed to run all the notebooks. And once he's done this, then he's going to start doing this in the prod.
Right, Jerome, do you want to head back to the slides while we wait for the runs to complete?
Let's look at the slides real quick. So these last two are more a recap of what we've done. Is it opening? There we go. So this is from the data scientist point of view. Really, all he had to do, and this is the beauty of the solution, is that you can put the same strictness towards Git version controlling. You can apply it now to your data scientists just like you would with your regular software engineers. And all you have to do is for him to create a branch from master. He links his work items. Then he clones the master build like Kao did, renames it to match the branch that he's going to work on, then link it to the branch that he just created. And then at the end, once he's happy with his changes, merge it back into master. And that will then trigger this long pipeline here that will always keep all of the data scientists in the same up to date. So that I can now have a team of data scientists make their own different polls, and their own branches, work, commit, and then deploy to dev, and then later to UAT, and then to prod.
Right, thank you, Jerome. And let's check if the build is complete yet. If not, we'll jump ahead into summarizing the presentations and wait for this. All right, it's still waiting. So while we wait for the run to complete, we want to share some of the learnings that we've ran into with this customer. So one particular thing is that Databricks and its Git integrations is not in a super mature stage. So some of the things that you've seen, right? I was able to go into the notebook and manually click on the revision history and link it to Git. I would have to do that for every single notebooks that I want to change. Currently, Databricks does not support synchronizing multiple files / folders from GitHub to Databricks. And so that's one thing. The other thing that we noticed is that there are not many out-of-the-box Databricks tasks in Azure DevOps. So here are the three that are there. So deploying notebooks that we've seen in the release pipelines, deploying files like data to DBFS, deploying Databricks secrets from Azure DevOps to Databricks. Those are the only three that are supported at the time of this presentations. But other than that, you have to do everything either through AZ CLI or Databricks CLI. And because this was a demo material, there are some things that we didn't do, but we want to call out about. So for enterprise customers, right, in many cases, you want to put your various environments into different subscriptions. So for example, you want your dev environments, QA, prod, all three in different subscriptions. And what that allows you to do is that it enables you to take advantage of test dev subscriptions for the dev environments. The value of that is that it will give you discounts on many of their services that are offered. But one caveat is that it is not financially backed. It doesn't have financially backed SLA that our standard subscriptions does. So we recommend you to use dev test subscriptions for dev environments and standard subscriptions for QA and prod environments. And one other thing is that in many cases, the key vault and the storage account and the Databricks workspace are managed by different groups. In particular, key vaults might be administered by security engineers, which means that it would be in a different resource group. Storage account will be managed by perhaps corp IT, which will result in being in a different resource group. And Databricks workspace, right, will be administered by data scientists, which in turn results in a different resource group. So with that, let's take a look at the pipeline itself. Do I have to refresh this? Is that why?
I don't know. No, it should be live, but let's go to pipelines. 10 minutes.
Yeah,
we had the time, but we promise you it worked so many times before.
Right. So, any questions so far? So, if this goes through, at least for dev, we can see it in action in dev. But as
maybe you
Jerome,
can show them in the Databricks. That now in master build we have the new code.
Yes.
That should prove it actually.
And actually, we can see the job actually running in Databricks as well. So let me show that. All right. So this is the Databricks workspace that we were just out of. So if we go back to clusters, let's see. Oh, okay. So something just terminated because if something is running, if Azure DevOps invoke a job that is running, it will be shown in this UI, a job clusters UI. Let me double check real quick if the job has finished. Refresh.
Yeah.
Voila. So it is a refresh kind of thing. So all right. So let's come over here and let's go over. So first thing I want to show is the master build file folder. So remember that we made the change to this featureization notebook. So we commented the first line and uncommented the second line. So again, this is reflected near real time. So if we actually look at the data itself, right, and what it looks like now. So if we go back to users, my directory and DataFest. So before, it used to be a data frame of 3 columns. But now if we run all of this, so what we expect to see here is the training and testing data should now have 4 columns instead of 3. And again, before this, I didn't run any Databricks notebook. Everything was executed through Azure DevOps. And of course, it's going to take some time.
And maybe we can take questions because I think the next session starts in 7 minutes.
Right. Yeah. Questions? No questions.
There we go. 4 columns. Brilliant.
Right.
Let's set this in.
Thank you for the applause. All right. So thank you, guys.
Thank you all. Bye.